Okay, so can you hear me?
Yes.
Okay, great. So good afternoon, everyone. So today we're gonna go through our last lesson for this week. So I've also attached the lessons materials so that you can actually download them from Mega. Before we start, are there any questions as to the materials that we saw yesterday, the day before yesterday, perhaps? You know, any comments? Is there anything you'd like to discuss? Or perhaps a link that you would want me to post again so that you can actually um, get part of the course material in case you haven't? Okay, so today's meeting or lesson is going to be a bit briefer because we are basically going to see how we can actually automate the process of basically classification and maybe even clustering in some cases. So in order to do all this, of course, let's go through our basic, strategy or pipeline, the main steps that we are always running into. So the first thing that we got to do again is activate our virtual environment and then open our Jupyter notebook, of course. And then we can go through today's lesson or notebook in this case. So what do we actually do once again in terms of the strategy that we will follow in order to perform our analysis? Well, not a lot of things have changed in terms of the steps or the code that we're going to write. So the first thing that we got to do is actually import all of our necessary libraries, as you can see here. The next thing, of course, would be to initialize any homemade function that we might have created, but in this case, we don't really have any. So we move on with basically loading our data set. So we are going to be using Iris once again, and this is basically the last time that we're going to use Iris. And the reason why I mention this is because in our next meeting, which is going to be at the 10th of December, we're actually going to check out a real world, biomedical example. So we also have to normalize or scale iris before we move on, pretty much as we've done yesterday and the day before yesterday. And now let's move on to the good part, Pike array essentially. So back then, if you actually wanted to run a lot of different classification models, so let's start with supervised learning or classification, at least at first. So back then, if you actually wanted to run multiple classification models like KNN or SVM, decision trees and whatnot, you would actually have to go through scikit-learn. You would have to check out the syntax, the code syntax, of course, and the different parameters that the algorithms require. You would have to initialize each and every single one of them manually, just as we've done yesterday, and then basically implement either cross-validation or train test split, and basically, train and later on evaluate your algorithms depending on the results that you get on the data set. So what PyCarray actually offers is a way to automate this whole procedure. So instead of actually running every single algorithm like one after the other in a manual manner, what PyCarray actually does is run every single one of the algorithms that are included in packages like scikit-learn automatically, like one after the other, without us having to initialize and then train and then evaluate, every single one of them. So even though the name actually might be a bit of a point of a confusion, because Carray is also a very popular package in R programming language, which is used for statistical analysis and machine learning. This is actually, quite different. So this is basically an automation of standard machine learning procedures, at least when it comes to classification and regression tasks. So in order to be able to use PyCarry, what we would actually like to do first is basically set up our experiment, right? So in order to do this, we are going to use this piece of code right there. You're going to also notice that this time we do not really have to separate the target variable, this one right there, the species that we have, from our data set, because the only thing that we got to do is basically specify the target right there. So by doing that, we essentially tell PyCarry that out of all the features that you have inside the data set, all of our columns, this particular one is our target, or tag. And if I go ahead and run this, and this is also a session ID there, it's basically a number that can help me differentiate this experiment from other ones if I'm running multiple experiments. But okay, there we go. So as you can see, this is a summary that I get. I didn't really do anything other than run this particular, code cell right there. So the target is species, as you can see. It's a multi-class target, so PyCarry was able to detect this for us. And what it also did is that it basically encoded the different species that we have into their numerical representations. So instead of having to implement some sort of dictionary or a label encoder, PyCarry basically went on and did this for us, right? And of course, you can see here the data shape. So we start with 150 samples and 5 columns, of course. And then you basically have 105 samples that are going to be used for training. And then you basically have 45 of them, which are going to be used for testing or evaluation over algorithms, might I say. And another thing that it kind of does, which seems kind of redundant, is that it basically runs stratified k-fold cross-validation on the training subset of the data set. It might seem a bit weird or counterintuitive, especially considering everything that we've been talking about. And this is pretty much why the reason why we might want to use PyCarry is for research or insight purposes, at least for starters. Like before choosing a particular, specific algorithm, classification algorithm, that is in our case, it would be best to just use PyCarry in order to basically get a better insight in terms of the information that we get out of all of this, and then essentially choose the best performing model according to some criterion like accuracy or F1 score or something different, some other metric, and go on with this one in terms of fine-tuning or using it into different data sets for evaluation purposes and whatnot. So since our experiment is now set up, the only thing that we got to do in order to run said experiment is actually, execute this line of code right there. And we are going to wait for a bit so that it can actually run. But the beauty, the whole magic of this is that, as you can see here, as the experiment runs, we are getting, the evaluation on the performance of many different classifiers, right? And then we also get the best results for each of the metrics that we use highlighted in yellow. So in our case, the best classifier is actually quadratic discriminant analysis. This is, a linear model, okay? And best here is essentially means that out of all of these models that PyCarry run for us, the best one is actually going to be stored as a variable so that we can use it later on for further analysis and evaluation. And how is the best model determined in, the case of PyCarry? So essentially in default settings, the best model is the one that actually has the best or the highest accuracy score. Could we actually define the best model by using any other kind of metric? Sure. I mean, we could have used recall, F1, or maybe AUC if it actually made any sense for a particular kind of scenario. But let's just go for basics or the default settings, at least for now. So after we've obtained the best possible model for PyCarry, the next thing that we can do, just as we've done just as we've done yesterday, is actually implement this thing right there. So as you can see, through a simple line of code, once again, PyCarry is also able to produce my confusion matrix, which actually serves as the basis for my evaluation. And the reason why it has actually changed, at least in this case, is because we are now taking Iris into account as a multi-class classification problem. So this is the difference between binary, as we've seen yesterday. We would have had, an array which would be something like these first parts right there, and the difference between this and having something that is multi-class. So that being said, would anyone like to try to give an interpretation of the results that we're getting? For example, what does this 15 right there actually mean for us? Especially considering that on the x-axis we have the predicted class and the true class is on the y-axis. So what is this 15 or this 14 right there, or this 15, whatever you might want? What do these values mean for us? Would anyone like to, give it a try so that,
If I may.
Of course.
I think the 15 and 14, for example, if I take the 15, it means that there in the test sample, there were 15 like classes too, and we predicted 15 of them correctly.
Exactly. So yeah, this is pretty much it. So if you take either this 15 or that one, it basically tells you that there are 15 samples of class 2 or 0 in this particular case, and they're predicted to be 2 or 0 again up here, and truly they are 2 or 0. So this basically tells us that the algorithm managed to basically make correct predictions for our test set, at least for the most part, because we also have this one here. So would anyone also like to try to interpret what this actually means, this one value right there that we get in the matrix?
I would say it's actually class 1 that was predicted as a class 2.
Yeah, exactly.
So it's a mistake.
Exactly. So this basically showcases the error in terms of the prediction error that quadratic discriminant analysis run through for one particular sample. So considering everything we've said so far, I mean, as well as what we've said yesterday, would we actually consider this performance of the model to be acceptable? Is it something that we would expect out of an algorithm, especially considering the data set? Is it something that we wouldn't expect? What would be your an interpretation that you would, give out, considering everything that we've been talking about, over the past days? Okay. Anyone willing to give it a try? No? Okay, so the answer to that is that yes, the performance that we get is acceptable. It's more than acceptable. It's actually very, very good. I would say that it's ideal, especially considering the confusion matrix and the results that we get up here in terms of our metrics. But it's also something that would be expected, right? And what is expected and what isn't is always dependent on your data set. So the reason why I say that this performance is something that we're expecting out of an algorithm, even if it's simple, like LDA or QDA or what have you, is simply because we're using a benchmark data set, like Iris. So would we actually have the same kind of performance in a real world problem, in a real world scenario where patterns, data patterns and whatnot are more intricate and perhaps even nonlinear in a lot of cases, well, maybe, but probably not. I mean, in most real scenarios, we would get many more samples as misclassified. And this is basically one of the things that we're going to notice if we run PyCarry on a real example, which is what we're going to do, at a later date pretty much. So what else can we actually do in terms of plotting? We can actually, plot bars like this. So the reason why we actually like this, or this might be helpful, is because it shows you the number of predicted classes and whatnot, the number of samples for each predicted class, and then it basically shows you the actual class as well as with, color coding. So what we can actually see here is that out of the total predictions that were made for samples that belong to class 2, for instance, there is a very small proportion of samples that actually belong to class 1. So essentially this one sample right there, in our case, is what we see here, which has been misclassified as class 2. And we can basically see that the other predictions that were made were actually fairly accurate and, clean. Another thing that we can also produce is this thing right there. This is more of a heat map, so it caters back to what we've seen in our second meeting, which basically showcases results for specific metrics. So you can see that we get precision and recall, we get F1, and we also get support here. So what this support value means is basically the number of samples that belong to each of our categories. And you can see that we have category 0, 1, and 2, which are the numerical representations of our categories. So we basically get 15 samples from each, which is basically the test subset that we have. So 45 samples. There are a lot more plots that we can get out of this. In fact, let me stop sharing my screen and let me also get into the PyCarry's main page so that we can actually check it out a bit. And just another point here to make, PyCarry is a bit slow when it comes to installing it, which is pretty much the reason why in most cases, when we try to install it through our VNV, it required quite a lot of time. So I imagine that, you're able to see my screen once again. So this is basically the doc page for PyCarry. The nice thing about it is that you can actually get tutorials that are available through their main page. If you don't want to follow the basic steps that are there, and you can see that they have a wide variety of problems, so you can actually check what's going on for binary or multi-class classification. You can check out what's going on with regression. You can check out for clustering, which is what we're going to do, in a teeny tiny bit, time series. So they basically have tutorials for many different kinds of problems for many different kinds of data. And let me also give you this link in the chat so that you can actually check it out if you want to. Oh, I can't? There you go. I think you can basically check it now. Just so that we can actually see some more, plotting options. Let's go to the binary example, if it actually let us use it and whatnot. So there is another thing that you see here. You can also run it through Google Colab, which is an online service. So if you don't want to run PyCarry on your own PC, you can, of course, use it through Google. This is a very good service that they provide. You could also use a GPU through the service in case you want to run with an artificial neural network. And you can pretty much see that the strategy is the same as what we had with multi-class classification, and we pretty much get the same series of results, but this time for binary classification, as you can see there. And what I wanted to get at is that you can also produce plots such as these. So you can plot the under area curve, so the receiver operating characteristic curve, which is pretty much what we've done, yesterday in a manual manner. You can also get feature importance in case the best possible model was a tree-based classifier, something like a decision tree, or maybe an ensemble of trees like a random forest or XGBoost. But we're actually going to see later on what these are in a different date. And you can actually also make predictions, which is pretty much what we could also do in our case. So you can basically use the best model through this function, and we can, copy it so that we can try it ourselves in order to make, a final prediction based on what we actually have. So yeah, you need to define it first. So I'm going to run through the example again later on so that we can actually, check it out. So that being said, of course, it also includes many different parts for fine-tuning and, using many different parameters for your best model. So you can see that it basically has a very simple, benchmark data set. This is a clinical one, but this is not the one that we're going to use for our own analysis at the 10th of the month. And then you could also save the model. I mean, after you're done, after you've managed to perform any kind of fine-tuning, you could basically save your best model along with the optimal parameters that are used for it. And you could also do a lot of other things. Like if you go back there and use the API, you could also change the way the experiment is run. For example, you might not want to run stratified k-fold cross-validation. You might want to change out the number of folds from 10 to something different, and so on and so forth. So this is pretty much it for classification, at least for starters. So is there any questions so far? Anything you'd like to discuss about PyKarray or, the results that we get out of this? Okay, so the question again might be here. So does that mean that since the PyKarray actually gives me out that the best model is, for example, QDA, that I should only be using like QDA and nothing more than that? Well, that's not really, you could actually go for this if you want the simplest possible solution, but in most cases and in most, research projects, that's less than optimal. So what you would actually do in a real environment, in a real project, is that you would actually get a list of models like this one right there, and then you would actually pick the top 5 or something a bit less like the top 3, for instance, in some cases, and you would check them further on your data set, perhaps using a different normalization technique, or perhaps even after feature selection, like after eliminating some of the columns that you have within your data, provided that you have a high dimensional data set, which means that you have an awful lot of features, like thousands or even tens of thousands of features in some cases. And then you would basically go on to make your final choice based off of based off of rigorous testing and, experimentation. And just because we might experiment with many different algorithms doesn't mean that we're actually going to stick with just one, at the very end. We could also pretty much combine their predictions and create some sort of our own ensemble or stacking model, which will actually take into account the predictions that are made by the many different algorithms that we have at hand. So again, I'm getting kind of ahead of myself here. So is there Anything you'd like to discuss? Let me ask once more. Anything at all? Any comment? So is everything understandable so far in terms of at least how we can run an experiment using this automated method?
I was curious about PyCaret. Like, it's not fully customizable, right? Like, we cannot fully customize the models.
Yeah, exactly. So this is basically, I'd say, like kind of a problem with many different libraries, depending on what library or package, we might be using. So all the packages that we use actually come with a set of parameters that we can always customize and, modify to our own needs. But unfortunately, if you want to create something that will be 100% tailored to your own needs, then in most cases, you would actually have to go, above and beyond the boundaries of said libraries. Like, for example, if you want to run an experiment which is going to be completely different compared to what PyCarret actually offers, it can be either in terms of models, in terms of the methodology that it uses, or something different entirely. Then it would probably be best to, start out with something from scratch. But creating something entirely new, so to speak, requires a lot of time, a lot of debugging. It can be quite of a frustrating process, but it can also provide you with a lot of experience. And at the same time, at the end of it, of course, an automated pipeline that is going to suit your needs at 100%. It's going to fit like a glove. But PyCarret and tools like PyCarret are not, again, panaceas. Just because they exist, it doesn't mean that we have to use them and only them exclusively. It doesn't mean that we have to basically retort to compromise basically to the parameters that they include, which basically means that sometimes they might not really meet our requirements. So in such cases, we would have to find different solutions. But thankfully, the good thing is that even if someone is not really experienced or doesn't really like coding all that much, you can actually get a lot of help nowadays from LLMs like, ChatGPT or Claude, for example. So even if you don't know how to write code all that well, you can actually have a very effective co-pilot by your side that can guide you into creating, your own code effectively and perhaps with less frustration as what might have taken place like some years ago when these models didn't really exist. So yeah, this was kind of a lengthy answer. Sorry for that. So was there anything else?
No, it's okay. It was interesting, yeah. And I think that for simpler ML algorithms, like even implementation from scratch, I mean, it shouldn't be that hard. But when it comes to neural networks, especially when you use like convolution, all that stuff, I mean, for me personally, using libraries makes sense at that time when there are things that would be really hard to implement. But for example, for simple cases like linear regression or other types of algorithms that are rather simple, it like doesn't make sense to rely that much on this kind of libraries.
Oh, definitely. I mean, when I say that we set up experiments from scratch, yeah, you could actually make linear regression, by ourselves, perhaps from scratch, but that would also be kind of tedious. What I meant to, relay is that instead of going through, something like PyCarret, it might not always, meet our requirements. So instead of actually using a library that automates procedures for us, we can actually automate the procedure ourselves. Like we can actually use existing, tools. I mean, the linear regression model that already exists within um, something like scikit-learn, it's also available in some other libraries, I think, but okay, is actually a very good implementation of the algorithm itself. And same goes for, this is a regression model, of course, but same goes for the classifiers that we've seen, like KNN, SVM, what have you. They are actually very good, and I would say optimized, implementations of these algorithms, especially for, Linux or Unix-based systems. And the same pretty much applies with neural networks, as you've said. Like, going on to create a neural network from scratch on your own, I'd say that this is going to be a complete hell. This is going to be a nightmare. So you should always use tools that are available. It's just that sometimes automation would actually have to be carried out by ourselves and not through libraries like PyCarry. Is that always the case? Like, should we always automate things ourselves? Well, no, you can always start out with trying things. You could always run your dataset through PyCarry, for example, and check out the results that you're getting and whether these are, acceptable or optimal for what you're trying to do. You could play with the available parameters so that you can actually check how that would actually affect your final decision. And if none of these actually meet your requirements in terms of automation, once again, you could basically automate the process yourself, which is pretty much like what you would do if you were in a big project and, wanted to have a big pipeline for many different, tabular data, like many different data sets that you would actually have to run through. But yeah, I mean, implementing algorithms for scratch, to be quite honest, there is no real reason to do that anymore. Like, implementing linear regression, for example, or implementing k-means from scratch, if we are talking about clustering, or KNN, if we talk about classification, is actually going to be very useful in terms of learning, because it will actually help you understand the very core of the algorithm itself. It's actually going to help you realize how it really, really works, so that you can get a very deep understanding of what's going on when, these algorithms are trained or when they make predictions. But aside from this, there is no real reason to go through that kind of process. So you could always use things that are ready, like things, again, from their core simple libraries that they start out with, scikit-learn or something similar to that. And then basically find a way to, again, automate the process by yourself. So instead of using something like this scheme that PyCarry does, you could actually create this part, the automation part, yourself, and also add something different. For example, instead of simply running, evaluation and training, you could also add an optimization algorithm through which you would actually fine-tune your algorithms on the go. It would perhaps be more computationally expensive compared to just, training and running them. But this might actually be, some sort of a requirement or an ideal thing to do for whatever reason. Of course, depending on the context and the project that you might run into. Again, kind of a lengthy answer. Sorry if this is tiring. So,
no, thank you. Thank you.
No, you're welcome. So let's also check out, just to wrap up, because, today is actually going to be a bit of a briefer presentation. So we can actually go through PyCarry, and this time we can also basically run clustering through it. So the difference between clustering and classification in PyCarry is that clustering is not as automated as classification is. But we really like it because, or you might like it because it actually includes a lot of very interactive, plottings, like, dimensionality reduction and whatnot. So how would we actually go on to run, clustering with PyCarry? So we would set up a clustering experiment this time. Again, we would give out our data set to the algorithm itself, and we would also specify the columns that need to be ignored. And the reason why ignore species is because we are now in the context of unsupervised learning. So we have to ignore or not take into account the ground truth that is available to us, at least as far as clustering or assigning samples to specific group goes. And as you can see, this is pretty much what happens. And since there is no automation like running models sequentially, we can basically choose one model, of these. So you basically have a catalog of specific algorithms that you can actually use. So let's actually go with the simplest one, being k-means, pretty much like what we've seen before. We could also use dbScan or something different, but let's keep things simple. So as you can see, we very easily get results pretty much like what we've seen before, in our clustering notebook. These scores are pretty much reminiscent of silhouettes, so a higher value for this one, Kalinski, Harabats, I'm sorry if I'm butchering this, actually means a better clustering, and same goes for Davis-Bouldin. And then you can basically assign your cluster labels to your data set, and once you've done this, you can basically create a PCA representation of your data set just by using one line of code. So instead of having to initialize, PCA by ourselves and then converting our data set and then plotting it and using the cluster labels, everything is done automatically for us. And another thing that we actually get here, as you can probably see with my cursor, is that we also have a completely interactive plot. So this time I can actually check, I can hover every sample. I can check the cluster to which each sample belongs to. I can check the PCA values that I have for my two principal components. And I can also get, specific feature values, as you can see. So the pattern that we get here is basically the same as what we would have with the dimensionality reduction, since we're talking about iris. But what changes here is that now, instead of having a static plot, which only includes data points and perhaps even a legend, we now have something like this. And the nice thing about it is that we can also download this as a PNG. And of course, in a PNG format, it's not going to be interactive, it's going to be static. But in case we want to save this just to, include this into some sort of a presentation, we could do this quite easily, right? So another thing we could, of course, do, since clustering is done and we've assigned everything to specific clusters and whatnot, we could also use our ground truth now so that we can also use it as a label. And as you can see, we can basically use this to hover as labels on top of them. So you could get this chaotic, picture right there where you have a lot of different textual names hovering over our data points. But it actually helps us better understand the different categories to which our samples belong to. So again, we see here that we get Virginicas and versicolors together. It's basically an equivalent or an alternative to using colors as well as shapes to define clusters or different categories. And that might have been a bit more intuitive, I think. I would prefer this myself over that kind of thing. But again, this is actually interactive, so it might serve a purpose considering that there are different requirements for different projects. By the way, the library that runs through PyCarry, through which we are able to get these interactive plots, is called Plotly. So just for those of you that want to run through the algorithm through this, you can actually search it, as such. Now, another thing we could do in terms of plots is actually create a three-dimensional representation of our data set. And by default, PyCarry is using TSNE. So if we actually go through TSNE right there, and as you can see, I'm getting a completely, interactive plot. So I can rotate this, I can zoom in to specific samples, I can actually check what goes on for each and every one of my samples, in terms of the labels or the clusters. And this doesn't really, unfortunately, if you try to save this as a picture, it's not going to be interactive. Again, it's going to be static, pretty much like the previous plot that we saw. But it actually serves, I'd say, as a very good demonstration when it comes to exploratory analysis and perhaps even clustering, of course, because you can actually rotate this and get a very good view of all of your samples and the clusters they've been assigned to. So this is also a very good basis for creating interactive and beautiful reports that you will be able to hand out to your colleagues in a specific research project. And then there's also plots such as this one right there. Again, everything is completely interactive because of Plotly. And in this plot, basically, you can see the amount of samples that have been assigned to each of our clusters. So having said that, this was basically PyCarry. So again, does that mean PyCarry, it actually helps us automate procedures like classification and regression, and it also helps us, again, make things like clustering a bit more interactive, especially through plotting. Does that mean that we always have to use this for whatever kind of work we're trying to achieve, whether it is clustering or classification? It's a very good starting point, especially if someone doesn't really have a lot of coding experience, because as you can see, everything is very easy to run. Like, you simply write one single line of code and you get a plot such as this. But you could also go to something like, a more basic or bare bones build, like go through Plotly and check out what's available there. So with that being said, let's also check a few more sources. For example, what if I actually wanted to run through specific examples for machine learning models and I didn't really want to go through PyCarry because it's too simple or too boring. So let me share my screen again. Just as a basis here, if you want to run simple machine learning models, you could also go through scikit-learn. There is the API that they include, which basically helps you understand what goes on with each and every function that they include, as you can probably see. And then there are also a lot of different examples. So there's dimensionality reduction, and they also use Iris, which is an example that they have. There is model selection, which actually helps you understand which classifier or predictive model is actually going to be better for your own task. Pre-processing, they basically have all sorts of different examples for many different disciplines. So how can you actually go on and check these examples? Oh, you simply go through the example by clicking this button right there, and you have a classifier comparison. You have all these sorts of different instances. So if you want to run, for example, many different classifiers, as you can see, pretty much in a notebook style, you have all the code right available to you, through which you're able to get this final representation of what goes on. So this is your data set, and these are basically let me zoom in a bit. These are essentially the decision boundaries that are created from each and every one of our classifiers. So KNN, SVM, what have you. I should also point out that scikit-learn also includes tutorials as to how to create very simple and basic artificial neural networks. But if artificial neural network and deep learning is what you actually want to do, just for information's sake, so let me just search for something so that I can show you. So give me a minute. So if you actually wanted to go through neural networks and deep learning is something that you really like, something that you're really excited about, you could also use, tools or libraries such as PyTorch, right? And they have a lot of things. They have tutorials going on through there, as you can see, on how to basically build and run artificial neural networks. And there is also TensorFlow. So this one, TensorFlow, has been created by Google just for a bit of history. PyTorch was created by Facebook, which is now known as Meta. TensorFlow is actually a bit more popular in the industry, while PyTorch is a more popular library among researchers and academics. But each of them is actually a very good, starting point, a very good building block when it comes to using and running artificial neural networks. Since they've been also mentioned, so I'm guessing that some of you might actually be interested in something like this. If you actually have to pick between one of them, whether it's PyTorch or TensorFlow, I would actually recommend that you go with PyTorch, because they've actually done a lot of work on the library itself. They've added a lot of improvements, a lot of automation. So basically setting up and using either models from scratch or pre-trained algorithms is going to be far easier compared to TensorFlow. Also, a lot of projects that you're going to find using TensorFlow code online through pages like Kaggle or what have you, they actually include legacy code, which is kind of old and deprecated. So it will be kind of a mess to basically go on and debug these and start using them. So again, I went a bit ahead of myself just so that we can actually see a few more tools, a few libraries, even if it was just going to be a bit of a referential thing. Aside from the course materials, just as a point to get into the concepts that we've seen together over the course of the last 5 days, I've also uploaded 3 books on my Google Drive, and I'm providing you with the links here. So I actually downloaded them a while ago. They're very good. They've actually helped me clear things out in terms of a lot of the concepts that we've been discussing. So this is kind of like, think of it as my final gift to you, at least for this week of lectures and meetings. So again, today's meeting was actually quite brief because we've actually been able to run ahead of schedule and be able to talk about a lot of the basic concepts that we had to. So with all that being said, is there anything you'd like to discuss? Anything you'd like to talk about when it comes to everything we've seen so far? Maybe about the libraries that we've seen that I briefly mentioned right at the end here, or about anything in particular. So
I actually have one question. Which one would you recommend more, like PyTorch or TensorFlow?
Yeah. So I would actually say, so I've used TensorFlow a bit more myself because this was the standard, at least back in like 2018, 2019. It was a bit more popular back then. But coming back to it, like right now, I'd say that PyTorch would be a better kind of library for someone that is starting with artificial neural networks. I mean, they actually have, a framework which is more refined. TensorFlow also relies on Keras, which, and from what I've seen, the guys that actually develop Keras are actually making their own modifications that are not always compatible with the latest of TensorFlow editions. So if you don't want to run through such issues and a lot of frustration, I'd say that PyTorch is actually better. And if you're also familiar with the R programming language, there is also an implementation for R as well, which is called RTorch. So it's basically the same API, the same kind of interface, but for R instead of Python. So I'd say that PyTorch would actually be the way to go nowadays, especially if you're also trying to do something more complex and not just standard neural networks. If you're actually implementing something like graph neural networks that take into account spatial data from, between nodes and edges of a graph, for instance. So this is what I would recommend. But TensorFlow, if you want to check it out, yeah, go for it. I mean, at the end of the day, if, data science is the field of expertise that, you want to get into and basically see what's going on and, get better at, means that you will actually have to have proficiency in a lot of different tools. And that essentially means that you will also have to, get a bit of experience with PyTorch and TensorFlow, especially if we're talking about neural networks. But in any case, the final key takeaway from everything we've seen so far, I'd say, is that at the end of the day, running through specific algorithms, using specific tools is, as you've probably seen, fairly easy. Like being able to run things like PCA or a pre-processing scheme or a clustering or a classification algorithm simply involves a few lines of code. It's not like C, for example, and low-level projects. It's actually very simple to do, especially considering that you can employ the help of co-pilots like LLMs nowadays. But what really matters in any case is understanding why. Why are we doing all these? Like, why am I actually using, for example, PCA instead of UMAP? Why am I using classifier A instead of B? Same goes for their clustering algorithms. So the key takeaway, the key final conclusion, I'd say, from everything we've discussed is before going on and using, your algorithms and the pre-processing techniques that we've seen, it would be a very good thing, a very, an ideal solution, an ideal sort of way to approach your projects or problems to basically create a scheme of how you're going to start and what's the final result. Like, what's your final goal in terms of data science? What do you actually want to predict? And how you're going to get there, so that you can also answer to the main question, which is why we're doing all this. So again, I got a bit ahead of myself, so sorry if this was quite a tiring answer, but yeah. Is there anything else you'd like to talk about? Okay, just as a final point over here. So I'm going to give you something more, just a final token. So I also have an active GitHub repository. I'm sending you the repository here in the chat. So we actually have stored a lot of different data science projects. Most of them are oriented towards biomedical problems, especially with transcriptomic data. So if any one of you is interested in checking these out, or perhaps even contributing to these, like taking one of our pipelines and perhaps making it better or helping us, improve upon what we've already done, feel free to, contact me and, we can arrange something. So with all that being said, again, this was a kind of a brief meeting or a lecture for today. So I want to thank you all very much for being here this entire 5 days. So I hope you liked it. I hope that everything that we've said was even a teeny tiny bit of helpful. And we're going to be back together at the 10th of December where we are going to check out how everything that we've said applies to, real data sets. More specifically, we're going to check out a biomedical example. And in the 17th of December, we are also going to check out, some artificial neural network architectures. So we can see how we can use advanced, deep learning tools in order to make predictions, again, for biomedical applications, which are our field, which is my field of research. So again, just before letting you go, is there perhaps anything you'd like to say? Is there any bit of feedback that you'd like to share? Oh, thank you, Vasilis. Thank you very much. So you're amazing
thank you
too.
for doing it.
Okay, so thank you very much, guys. I mean, you're amazing too. So thank you for putting up with me, even though it's like a bit late and you also had a lesson before me. So yeah, this is pretty much it. Oh, thank you, Derek Bohr. Thank you very much. So thank you. So with all that being said, so I'll see you around. Again, if anyone wants to send me a message for whatever, always feel free to do so. You already have my email, so I'm going to type it once again for you in case you want to make contact. So this is it. And oh yeah, go ahead, George. Random question. Yeah. Okay. I'm there for it, so hit me up. Thank you very much, Andrea. So George, you could also open your microphone if you want to, like, you know. Oh, I'm a PhD candidate at the Ionian University. I'm at the Department of Informatics. So for those of you that are students at the Department of Informatics in Corfu, I'm also going to potentially see you up close at the 10th of the month because I'll be there. So for those of you that are not in Corfu or in Greece, you're more than welcome to visit. We'd very much be delighted to have you with us. And for everyone that is in Corfu, I'll see you up close. You can, yeah, so you can come up and, have a meet and greet and perhaps even share a coffee or something. So again, thank you very much, guys. Like, it's been a very delightful experience for me as well. So um, with all that being said, I wish you a good weekend and I'll see you around. So have a great night.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye. See you around.
Thank you. Bye-bye.
Thank you. Goodbye.
Excuse me, Professor. I just wanted to ask like two things about the course in general.
Yeah, of course. Tell me. Go ahead.
So the first question is like from next week we're going to change subjects. So I just wanted to ask actually before the whole thing started, they've sent us an email where we filled out a form of like subjects we were interested in, and I just wanted to ask. So we only join the subjects we have filled out that we're interested in, or do we join all of them except, of course, for the ones that are mandatory?
I don't really know this. Like, I'm really not aware of, how things are set up in terms of the choices and whatnot, but I'm guessing that anyone that is part of the course can actually, take part in pretty much any lesson they want to. So if there is a particular lesson, I'd imagine that you've changed your mind on something you'd like to attend and perhaps you didn't include in your application, I'm sure that you are, more than welcome to do so. But don't quote me on that. I mean, I really have no idea. I'm not aware of this. So
Yeah, I just wanted to ask because like the form itself only allowed us to actually fill in 4 different subjects, no
Mhm.
more than that.
Okay.
And I mean, it makes more sense if they were like, you only are able to join the classes and the subjects you filled out, but I don't know, at the same time they've sent the links to every lesson, so I just wanted to ask, maybe you knew.
Yeah, unfortunately, I can't really answer that for certain because I'm not really aware of how things are organized for every lesson. But I think you can. I mean, since you have a catalog of the lessons and the links, then perhaps you can. I mean, sure, but just be 100% certain for this. I'd recommend that you actually contact someone like Professor Themis Exarchos, for example. I mean,
All
I
right.
think that I think that he will be able to give you, a concrete answer to your question.
All right.
So,
And I also have one more question,
mhm.
and it has to do with like when the whole Erasmus project is over, will there be like an exam or some type of project we have to do before we can get our verification? What's like the process in that?
Okay. So once again, it's going to be like of a bummer answer, but I don't know that either. Like, I think it's going to be some sort of a project, like an optional project if you want to, take part in it. Like, it will be based upon everything that we've seen, together and through, I'm guessing, any other course you attend. But that's not certain either. Like, it's on the table, but I don't really know. At least
I
not yet.
see.
But in any case, you will receive like a notification, in due time, whether a project or some other form of examination, applies. I mean, I don't really
All
know
right.
that. But in any case, it's not going to be something, if it is an examination or a project, it's not going to be something hard. It's actually going to be, things that are going to be based off of the things that we've seen like together. And considering that you already have access to the course materials, for example, at least in our case, I think that it will be a breeze. It will be very easy to run through.
All
So,
right. That's all. Thank you very much. Have a good afternoon, and thank you for the lectures. Your
oh,
explanations were always amazing.
thank you for attending. I mean, very glad you liked it. So there's also another question from Ioannis. How to change the Python version in Jupyter. So in order for you to do this, you would actually have to either install multiple versions of Python in your computer, which is something that I would not really recommend that you do. The second course of action is to actually play with not with standard VNVs, but actually install either Anaconda or Miniconda, which is basically like an optimized version of the library. So what that will actually help you to achieve is create a Conda environment. So it's basically an equivalent to the virtual environment that we've seen together. The main difference being that you could also specify the exact version of Python that you want to work with. So instead of simply using Python 3.10, which would be a staple, at least in our case, you would also be able to specify that you want to use something like Python 3.9 or 3.12 or 3.13. And aside from this, aside from Conda, there is also UV. It's another kind of system that basically allows you to create. Okay, great. So um, I'm guessing that the question is because there's probably some issue with PyCarry. Is that it? And the reason why I say this is because I've used 3.12. I've tried to use 3.12 with PyCarry, and unfortunately, it didn't really work. Like, at least in my case, it was problematic. I run into all sorts of compatibility issues. So, hence the reason why we use 3.10, because it's well established that it works with this particular library. Yeah, yeah. So this is exactly the reason why I've actually recommended 310 or 311. So this is not really like your problem, so to speak. It's not a problem of Python. It's more like a problem with PyCarray. So, and here's another thing that goes on with specific libraries and implementations. Like some of them may be, very good and easy to use, but they might be neglected for quite some time, and they might not keep up with, the latest improvements in, whatever language we actually use. So in that case, the problem is that truly PyCarray actually has compatibility issues with anything, above 311. So to get around this, I would actually suggest using, instead of, keeping things a step up and basically going from something like a standard VNV to Conda, for instance. And just so that we make things even clearer, let me also provide you with a link. And let me also, this is for Anaconda itself. And let me also provide a link for Miniconda. So I would actually recommend in going for something like this, just so that you can have a bit more, flexibility, and it's going to be a bit more complex. Not a lot, but a bit more complex compared to what we've seen so far. But I think it's also a good thing to do if you want to, in order to gain a bit of a more of an experience in terms of, coding and how to set up environments. And the reason why I say this is because aside from standard VNVs, Conda environments or mini Conda environments are also very prolific in many different, data science projects. So it never hurts to get a bit of more of an experience with these as well. At least I'd say. So, and they have a series of steps that you can follow. They are very well documented. So it's going to be a fairly straightforward process. So, yeah. Okay, so I'm guessing that this pretty much wraps it up for today. I mean, I don't think there are any questions that I've missed in the chat. So once again, I'd like to thank you very much for being here with me. Thank you very much for your attention. Once again, I hope that everything was actually helpful and easy to go through and understand. And I'll see you at the 10th of December. So see you soon. Have a good night.